There is a moment just before it happens when everything looks normal. The stars are still there. The darkness between them is the same darkness it has always been. Your body feels nothing unusual, no pain, no pressure, no warning. Then the light starts to bend. Not dramatically, not the way it does in films, just a subtle curve at the edge of your vision, like the universe is leaning slightly in one direction. You notice it the way you notice a sound you cannot name. Something is wrong, but your mind does not have the word for what it is seeing yet. You are approximately 600 kilometers from the event horizon of a stellar mass black hole. Based on the calculations of physicist Kip Thorne, whose work on gravitational effects near singularities shaped everything we understand about this moment, you have roughly 4 minutes before crossing a threshold that has no exit. Not 4 minutes to escape, not 4 minutes to radio for help, 4 minutes in which the concept of escape still has meaning. After that, it does not. Your first problem is not the black hole. Your first problem is what it is doing to the space around you. General relativity, the framework Albert Einstein completed in 1915, tells us that mass bends space-time. Everything with mass does this. Your body does it. The planet you came from does it. The sun at the center of your solar system does it in a way you can measure by watching starlight curve around its edge during an eclipse. But a black hole does not bend space-time. It rips open a pocket in it so deep that the pocket has no bottom. The closer you get, the more every direction you could travel in curves toward the center. Space itself is no longer neutral. It has a direction, and that direction is in. You are moving at roughly 11 kilometers per second. You did not choose this speed. You were not propelled toward this thing. This is simply what falling into a gravitational well feels like when the well is deep enough. Physicist Neil deGrasse Tyson has described this kind of free fall as the purest form of weightlessness a body can experience. You feel nothing. Your inner ear reports nothing. You are not being pulled. You are following the only straight line left in this region of space, and that line ends at the singularity. The light around you is changing now. Objects directly in front of you have begun to compress. The star field that was spread across 180 degrees of your vision is gathering toward the point you are falling into, bunching together as if something is draining it. This is called gravitational lensing. The black hole is not just consuming matter, it is bending every photon that passes near it. Stars that should be behind the black hole are visible now, displaced. Their light has curved around the object and reached your eyes anyway, ghosted into impossible positions. You are seeing a star that is, from any classical frame of reference, directly behind the thing that is about to end you. That star is sending you light that has traveled a curved arc of millions of kilometers just to arrive at your retina in this specific moment. You are 3 minutes out. You should know something about what you are actually falling toward. The term black hole is misleading. There is no hole. There is no void. There is a region of space where the escape velocity, meaning the speed something would need to travel to break free of gravitational pull, has exceeded the speed of light. Nothing travels faster than light. Therefore, nothing leaves. The boundary of this region is called the event horizon. It is not a surface. There is nothing physical to touch or collide with. It is a mathematical threshold, a point of no return, a line in space that has no texture, no color, no temperature of its own. If you could see it from the outside, you would see nothing where it is. That is the point. That is the whole architecture of the thing. Inside that boundary, according to the singularity theorems proved by physicist Roger Penrose, all paths through space-time lead to the same place. Not most paths, all of them. You cannot orbit inside the event horizon. You cannot hover. You cannot slow down. Space-time inside the event horizon only moves in one direction, and that direction is the singularity at the center, the point of infinite density where the known laws of physics break down entirely and produce only silence.
2 minutes. Here's what is happening to your body right now that you cannot feel yet. The gravitational pull on your feet is fractionally stronger than the gravitational pull on your head. This difference is tiny at this distance. It is not zero, it is growing. This phenomenon has a name: tidal force. The same mechanism that creates the tides on the planet you came from, that slight differential pull across a body due to proximity to a massive object, is acting on you. Right now, the difference is immeasurable. At the event horizon of a stellar mass black hole, the kind with a mass a few times that of a star, the tidal force across the length of a human body will exceed every material strength the human body has. Researcher Gaurav Khanna at the University of Massachusetts has modeled this process in detail. The technical term is spaghettification. It is not a metaphor. Your body will be stretched lengthwise and compressed laterally, like a strand of dough being pulled slowly apart, until the atoms that compose you are no longer recognizably connected to each other, not immediately. The process is gradual. It will begin at your extremities. You cross the event horizon. Nothing happens. This is the part no one expects. This is the detail that makes the whole thing worse when you sit with it long enough. You do not feel a wall. There is no sensation of crossing a line. No change in temperature. No flash of light. No resistance. From your frame of reference, from the point of view of your consciousness in this moment, the event horizon is invisible and frictionless. You pass through it the way you pass through a beam of light. The light itself does not know you crossed it. Neither do you. But something fundamental has changed. Every direction you can now travel, including the direction that used to be backward, the direction that used to lead away from this place, now leads only inward. You can still move. You can still fire a rocket, kick your legs, throw an object. Every action you take simply traces a path through space-time that arrives at the singularity from a slightly different angle and at a slightly different time. Your agency has been preserved. Your destination has not. From outside, from the perspective of someone watching you fall in from a safe distance, you never cross the event horizon at all. This is where it gets strange in a way that is not a paradox, so much as a statement about what time actually is. As you approach the event horizon, time in your frame of reference continued normally, but an observer watching from outside would see you slow down. Your image would stretch and redden as the photons escaping from you had to fight increasingly severe gravitational potential to reach any distance at all. You would appear to halt. You would appear to hover at the edge of the event horizon for a very long time, growing dimmer and redder, the light from your body losing energy as it struggled away from the gravity well, until you were too faint to see. To the outside observer, you never crossed. You are frozen there, a relic of a moment that approached but never completed. Inside, you are still falling. The tidal forces are noticeable now. You can feel the difference between your head and your feet. It is not pain yet. It is more like a deep pressure, a pulling sensation in both directions simultaneously, as if your body is being asked to be in two places at once. This is the beginning of the end of the physical form you arrived in. Over the next few seconds, the forces will compound exponentially. There is no mechanism in biology that addresses this. Evolution did not prepare you for this particular pressure, because nothing on the planet you came from ever encountered it. Your cells do not have a response. Your nervous system has no protocol. The sensation will be unlike anything in the catalog of sensations your brain was built to process. The singularity is close now. At the singularity, general relativity predicts infinite density. The equations produce an answer, and the answer is infinity, which in physics usually means the theory has reached the edge of its own validity. Something happens at the center of a black hole. The equations cannot tell us what, because the equations fail. This is not a gap in knowledge that future research will close by adding more detail to the existing framework. This is a fundamental breakdown of the language used to describe reality at the scales involved. Physicist Stephen Hawking spent decades working on what happens at this boundary. His conclusion, developed alongside Roger Penrose, was that singularities are real. unavoidable, and described by mathematics that stops describing anything coherent the moment you arrive at them. You arrived, and somewhere, infinitely far from where you are now, someone is standing in a dark room pressing a light switch. The room floods with brightness. They do not think about it. They cannot know that somewhere an event horizon exists where not even that light could escape. They turn back to their ordinary evening. The dark between the stars outside their window looks the same as it always has.